So 1.9 is a little bit of a review of what we would call some coordinate geometry. So really just plotting points, thinking about some formulas we can use to relate a couple of points, and a review of circles. So first of all, say I have two generic points, so x1, y1 and x2, y2. The question is, how do I find the distance between the 2 points? So as in, I'm interested in this distance. Well, the good news is I can actually create a right triangle here, and I can actually apply the Pythagorean theorem. So let me see if I can fill in the sides. In order to use the Pythagorean theorem, I'm going to have to fill in the lengths of the sides here. So let's see if we can figure that out. All right, so let's see. The first x coordinate here is x1. Second one here is x2. So this distance, wouldn't that have to be the difference x2 minus x1? Versus here, this is y2, this is y1. So this would have to be y2 minus y1. So by the Pythagorean theorem, wouldn't it have to be true then that x2 minus x1 squared plus y2 minus y1 squared is the distance squared? So the distance formula just looks like this, but it's really just an application of the Pythagorean theorem. Okay, so this is the formula I would use when I'm interested in finding the distance between 2 points. Now be careful, you can't cancel. And sometimes students will say, oh, I can cancel out the squares and the square roots, and this becomes really simple. No, that's like if you have the square root of 3 squared plus 2 squared. What is that? It's the square root of 9 plus 4. It's the square root of 13. Like, you can't make that 3 plus 2. No, can't do that. So when you have this sum in the middle here, you can't actually simplify the square root. So we're stuck with that as it is, but that's okay. It's not too bad. So don't make that mistake. Okay, oh, here's another formula. I mean, this one's kind of makes sense. The midpoint, the point halfway between 2 points, you just take the average. So you add the x's and divide by 2, you add the y's and divide by 2. And that will give you the point halfway in between. Okay. All right, so let's do a little application. So find the distance in the midpoint between these 2 points. Okay, so let's see, should I plot them first? -1, 1, and -6, -3. Okay, so first thing we're interested in is the distance. Okay, so I can use that distance formula. So how does that one look? It looks like this, right? So I do x2 minus x1, -6 minus -1. Then I do y2 minus y1. do the algebra. So I have a double negative. So that's -6 plus 1. And then -4 squared. 25 plus 16. So what is that? Square root of 41? 41 is prime. So let me double check. I always like to kind of look through these ones with multiple steps. Make sure I didn't do anything funky. Sometimes I still do. I think it looks okay. Okay. And then let me see if I can find the point halfway in between. So I mean, it's going to be like around here. Might even be at that point. Let's see how I did as far as drawing the sketch. So the midpoint, set up a coordinate pair. I'm going to be averaging the 2 x's and the 2 y's. Okay, so the x's, so -1 plus -6. The y's, 1 plus -3, so 1 minus 3. So -7 and -2 over 2, so -7/2, -1. So that should be the point halfway in between. So that's -3.5, -1. So let's see if it looks about where I was thinking it would be here. 1, 2, 3. Yeah, look at that. So there's the midpoint. So I did a pretty decent job on the sketch. Okay, let's see, standard form equation of a circle. So here if I have a circle centered at the point h comma k with a radius of r, here's the standard form equation. So x minus h squared plus y minus k squared equals r squared. So we start out asking find the center and the radius. Well, number 1 is actually a very simple example. The reason why is because actually, if you look at this formula, if h and k are 0, doesn't this formula just become x squared plus y squared equals r squared? So that's a special circle. That's the one that's just centered at the origin, okay? So when I look at the first circle here, I'm like, okay, well, this is just a circle with a center of 0, 0. Now, r squared is 25, so the radius is 5. So I mean, I don't know how many of these I need to graph. It's pretty easy. I'll do a rough sketch. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And I haven't found a great way to draw circles on the iPad. It looks something like that. Okay. Here's one that's more interesting. Number 2. Okay, so I've got to compare that because I need to read the radius off. I'm comparing that with the standard form. Okay, so I need to read off the center and the radius. Okay, so be careful with the center because you see how the h and the k are values being subtracted. Like I can read the y coordinate off immediately. With the x coordinate, you have to be careful because I actually have to think of this as like a double negative because I have to account for the subtraction in the standard form equation up here. So if that's confusing, I mean, there's an easy little trick you can use, which is, well, if I want to read off the center of a circle in standard form, I just think of it this way. I say, what value would make this inside of this parenthesis 0? -2. what number would make the inside of this parenthesis 0? 4. So that's a simple way to get the x and y coordinates, the signs correct for a circle. And then the radius, so r squared is 1, so the radius is 1. Let's see if this one is any more interesting to graph. Negative 2, 1, 2, 3, there's the center. The radius is 1. So I'd have a point here, 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 and here. Okay, looks something like that. Find the equation of the circle with endpoints of a diameter, negative 1, 1, and 5, 9. Okay, so, I don't know, should I plot the points? Negative 1, 1. Right there. All right, so I mean, this is going to be kind of interesting to try to graph, but so those are the end points. So that means the diameter is like this. So here's the center. So then the circle, I'm going to do a terrible job drawing this, but it's like something like this. Huh? Okay, I mean, it's a rough sketch. You get the idea. So I need to find a couple of things. I need to find the center. So the center, I mean, this is going to be an application of my midpoint formula, yeah? So the midpoint, how does that work? I take the x's and add them. Let's see, so negative 1 plus 5, divide by 2, I'm taking the average. Take the y's and add them, divide by 2. So what is it, 2, 5? So that's the center. So let's see, does it look like it's in the right spot? See if it's approximately correct. 1, 2, 1, 2, 3, 4. Yeah, look at that. That looks pretty good. So there's the center. Okay, so the other thing I need is the radius. So, looks like I'll need more room. I can move this up. Okay, so the other thing I need to get the radius. Okay, so what is that going to look like? Well, the radius is this distance, half the diameter, right? So that would be the distance formula, right? Looking at the distance between these 2 points. Be one way I could do it. So let's do that. So my distance formula, square root. Okay, I'm looking at this and this. So let's see, I've got y2 or x2, so 5 minus x1, 2, and then squared plus, let's see, y2, 9 minus 5 squared. Okay, so that's 3 squared, and then that's 4 squared. Let me just look and make sure. Looks like I wrote everything incorrectly. So let's see, I've got x2 minus x1 squared, y2 minus y1 squared. 3 squared, 4 squared, I think so. Okay, so then where are we? So then that's 9 and 16, square root of 25. Okay, so then I have my radius. So I've got my center and my radius there. So now I should be able to, it says find the equation. So let me go ahead and write out that equation. So, okay, the standard form equation of a circle looks like this, right? So I need to write that out with my information. So I'm going to have x minus, let's see, my center. So let's see, 2 squared. The OK was 5. And the R was 5. So 5 squared. There's my equation. Okay, here's something that we'll encounter a couple times throughout the semester. Find the center and the radius by putting in standard form. So here I have the equation of a circle. So how do I know it's a circle? Because I see the x squared and the y squared, x squared plus y squared. They have the same coefficient, as in the numbers in the front are the same. See, this one's a circle as well. Because I have x squared plus y squared, I have the same numbers in front of x squared and y squared. But, you know, I mean, if I want to put that in standard form, where did I write that? It's this equation. So that's my goal, because that way I can read off the center and radius. Okay, so there's my standard form. Okay, so that's the goal. Now, how do I put a circle in standard form? I have to follow a process. And the way we do this, we're going to use this technique in a few different contexts. So I do this using a process called completing the square. So there are a few techniques, a few ways to do this process. Okay, so here's what I do. So I'll kind of go through and I'll write out some of the steps. So first of all, I would rearrange. So I would make sure I have the x's together, the y's together. And then I would move the constant. So the term that has no variable, so the 12. Move the constant to the side opposite the variables. Okay? And I rearranged. All right, so then I look and I say, okay, is there anything multiplying the x squared and y squared? Like, you see how down here I have the 2 in front? I'd have to divide the whole equation by 2. We'll get to that in this next example. And this one, there's nothing multiplying the x squared and y squared, so we're good to go there. So now I have to calculate my special numbers. So these special numbers are b over 2 squared. So how does that work? Well, so we kind of think of this as like x squared plus bx, and then, you know, there'd normally be a c, and this is like y squared plus by plus c, say. So when we say b, we're thinking of the coefficient on the linear term. So on the term that's not squared, that has the variable by itself. So in this case, like I have 2 b over 2 squareds I have to find. I have to find one for x and one for y. So that's like side work. So these are kind of the steps. So we did that step and that step. So now where should I go to calculate these special numbers? I'll just do it down here. So for x, the b is 4. Okay. How about for y? The b is negative 6. Okay, now I'm going to add those on both sides, but in the appropriate spot, like as in, let's see, this cleaned up first. So for x, my special number was 4. So I'm going to add that 4 here next to the x's. For y's, my special number was 9. Now, I have to add those numbers on both sides of the equation, right? In order for the equation to stay balanced. So negative 12 plus 4 plus 9. All right, so I got, those are my special numbers. Let's look at my steps. So I mean, now I just factor. Because I'm looking for this nice standard form. So actually, I mean, these guys always factor. That's why these numbers that we add are special. So I'm like, okay, what adds to 4 and multiplies to 4? X plus 2 and x plus 2, right? So isn't that x plus 2 squared? And then for the y's, okay, what adds to negative 6 and multiplies to positive 9? Negative 3 and negative 3. What is that, a 1? Sure I got that right. Yeah. Oh, look at that. That's it. It's in standard form. That wasn't too bad. So then my center would be negative 2, 3. My radius would be 1. Okay, I won't graph another one. I guess that's pretty similar to the last problem. Let's try this next one. So same thing. All right, so we would follow these same steps. I'd say, okay, I don't know, I can even, should I take these down? Okay, move constant. Well, there's actually no constant in this one. So this step is done. I could rearrange. Let me put the x stuff together. Okay, let me find my special numbers then. Okay, so 4. Oh, well, let me see. There's one thing I'm missing, though. Be careful. So I should add this somewhere here. So let's say, remember I said that I have to check the lead coefficient if it's not 1. Remember in my previous example, I didn't have anything multiplying in front here. So if I have something multiplying in front, before I go on to find my special numbers, I have to divide the whole equation by that value. So let's see, then I'll have x squared minus 3/2 x plus y squared equals 0. Okay, so I don't want to go on to this step until I make sure that I have only 1's in front of x squared and y squared. So now I'm good to go. So let me find the special numbers. So the b over 2 squared let's do it this way. So the b is negative 3/2. Okay, so this one's a little more interesting. So top fraction stays the same. Bottom fraction flips. Multiply, so it's negative 3/4 squared. Square the top, square the bottom. 9 over 16. Now actually the y, look at this, there's no linear term for y. So actually the y is already done. Like, you'll see what I mean. So look, now I'm adding that special number. So I'm going to add it next to the x. That's what it pertains to. Add it on both sides. Okay, then I have to factor this. Now this always factors as a perfect square. But you see the y is done because like y squared is y minus 0 squared. There's no linear term. But how the heck do I factor this? Well, it always factors as a perfect square. So here's the thing. I mean, there's kind of a little trick. So let me see. Maybe I can show you in the last one. Let me show you in the last one. Okay, so when we're finding the special number versus when we're factoring. So look, see how for this last one, for x, when we were finding the special number in the last step here, we had a 2, positive 2. Look, this number here is positive 2. Look at for y. See how in the last step before we square that special number, we have negative 3? Inside here I have negative 3. Let me see if you can follow that same trick. So look, here's the last step before I square that special number. What do I have? Negative 3/4. Check it, see if it works. So look, if I was to FOIL that out, I'd have, okay, well, I'd have x squared, because I have, look, this is to check. I'd have x squared. I'd have minus 3/4 x, minus 3/4 x. So minus 3/4 times 2, x. And then negative and negative is positive. 3 times 3 is 9, 16. 2 and 4, look what I have. X squared minus 3/2 x plus 9/16. Isn't that what we have here? So it works. Okay. So that's just the checking for checking. So that's a nice little trick, especially if you're factoring with fractions. So what's another way I can think about it? I can go, okay, well, let's see. Negative 3/4, if I multiply it by 2, I have to get this number. So if I multiply negative 3/4 by 2, I get negative 3/2. Then if I take negative 3/4 and multiply it by itself, I have to get this number. So negative 3 times negative 3 is 9. 4 times 4 is 16. So different ways of thinking about that. So there I've got my circle in standard form. So let's see, my center would be 3/4, 0. My radius, so r squared is 9/16. So the radius would be 3/4. I don't know. Maybe I should try graphing one more, so you can see something with fractions. So something like that, I would probably scale the axis. So scale in fourths, like 1/4, 2/4, 3/4, 1, etc. 1/4, 2/4, 3/4, 1. Let's see if I left enough room. I may not have. Maybe I need to make my axis longer. Let's do that. Okay, let's try graphing it. Let's see what we get. So the center is 3/4. That'd be here. 3/4, 0. The radius is 3/4. So 1. Oh, maybe I have enough room anyway. Up 1, up 2, up 3/4. So that point is at 3/4 on the x-axis, 3/4 on the y-axis. Then to the right, so I'm at 3/4, 4/4, 5/4, 6/4. 6/4 is 3/2. Okay, left 3/4 is going to put me right at the origin. and down 3/4. And then try to make it look like a circle. Not that good at that part. Maybe something like that. Okay. So this completing the square trick, it comes up in several contexts. I mentioned that. So we'll be seeing that again as we continue.